So this video is integrated one, the semester 2 final review. This is homework 2. This is kind of covering chapters 3 and 4. So on this first section, we are dealing with multiplying out binomials or a monomial and a binomial. So what we're going to do is we're going to do an area model. So I'm going to make a box, a rectangle. I am going to have, because these are two terms here, a 2 by 2. So let me just get a 2 by 2 drawn. And so in this case, I'm going to be multiplying out an x plus 5 with an x plus 2. And when I do, I'm going to get an x squared. This is going to be 5x, 2x, and a 10. So x plus 5 times x plus 2, which is the area as a product, is equal to the area as a sum, which is x squared plus 7x plus 10. And I'm getting the 7x from this 5x and this 2x. That gave me the 7x. I'm going to do the same thing on the next one. So this is a 2 by 2 also. So let me get my box and let me get my 2 by 2 box. So for a little bit. Okay. So for this, I'm going to have a 2x plus 3 and an x minus 3. So when I multiply this, I get a 2x squared, a 3x, a negative 6x, and a negative 9. So areas of product is going to be 2x plus 3 times x minus 3. And that equals my areas of sum, which is 2x squared. And again, I have a negative 6x and a 3x. That's going to end up giving me a negative 3x when I combine it, minus 9. On number 3, we want to prove that whether or not x plus 7 squared is equal to x squared plus 49. So an x plus 7 squared is really an x plus 7 times an x plus 7. That's really what it is. So this is what we really are trying to see if these are equal. So I'm going to get a 2 by 2 box. And I am going to have an x plus 7 times an x plus 7. So x plus 7 times x plus 7. So this is going to give me an x squared, 7x. I get another 7x, and I get a 49. So I'll have a 7x here and a 7x here. So that's going to give me a 14x. So x plus 7 squared, because that's what x plus 7 times x plus 7 is equal to x squared plus 14x, because of this 7x and 7x plus 49. So is this true? False. That is not true. On number 4, I can do a 1 by 2 box, or I can actually even distribute. So this is going to be, let me just shift this over. This is going to be a 3x times an x plus 2. So that's going to give me a 3x squared and a 6x. So again, I could have taken that 3x times x, which would give me this 3x squared, 3x times 2, which gives me the 6x. So 3x times x plus 2, which is the area's product, is equal to 3x squared plus 6x, which is the area as a sum. On number 5, I can either do a 2 by 2, 1 by 2 box. Let me just get rid of that. A 1 by 2 box, Or I could also use distribution, whichever one you prefer. So when I'm doing this, this is going to be a 2xy times, actually, this is going to be, sorry, a 2 by 3. So I'm going to move this over. And let me get another one, sorry. So this was a 1 by 3. Because I have 3 terms here. So that's going to be a 2xy times an x minus 3y plus 8. So a 2xy times x is going to be a 2x squared y. A 2xy times a negative 3y is going to be a negative 6x y squared. And a 2xy times an 8 is a 16xy. So I end up having 2xy times the quantity x minus 3y plus 8, which is area as a product, is equal to the area as a sum, which is going to be a 2x squared y minus 6xy squared plus 16xy. So the next one, I'm going to fraction bust. So for this one, we do need to get, I would say I would fraction bust on number 6. So we want to multiply something to get rid of both of our denominators. We have a 6 and we have an 8. So we want to multiply by something that will get rid of 6 and 8. I am thinking 24. So I think I'm going to multiply everything by 24. So I'm going to go 24 times x over 6 minus 24 times 5 over 8 equals 24 times 4. And then 6 goes into 24 4 times. So I'm going to end up with 4x. 8 goes into 24 3 times. And I'm going to end up with a negative 15 when I multiply that out. And 24 times 4 is going to be a 96. I am going to add 5x to both sides. Sorry, 15 to both sides. And I'm going to get 4x is equal to 111. Then I'm going to divide both sides by 4. And I'm going to get 111 over 4 as my answer. On number 7, I could distribute my 36, but I think what I'm going to do is I have a 36 here and a 36 here. I think I'm going to divide both sides by 36. Divide this side by 36, divide this side by 36. When I divide this side by 36, 36 goes into 36 one time. And I'm left with an x minus 2 equals, and 36 over 36 is a 1. I'm going to add 2 to both sides. And I get x is equal to 3. On number 8, when I'm simplifying this, you can really think of this as a 3x cubed y times a 3x cubed y, if that helps you out. And when I have that, I'm going to have a 3 times a 3, which is going to give me a 9. I am going to have an x cubed times x cubed. When I am multiplying bases, I add the exponent, so that's going to be an x to the 6. And I am going to have a y times y, which is going to be a y squared. Another way to think about it is everything in the parentheses being raised to the power 2. So when I have a 3x cubed y raised to the power 2, I'm going to have a 3 to the second. I'm going to have an x cubed to the second, and I'm going to have a y to the second. So 3 squared is 9. X to the third raised to the power 2. Power to power, I multiply, so I get x to the 6. And y to the second, which is the same answer I got right here. On number 9, I'm going to distribute the 3 on this side. So I'm going to get a 3x minus 6. And on the other side, I'm going to combine like terms because I have some terms that are the same over here. 2x and x I can add. I get a 3x plus 3. I like to, when I have x's on both sides, get rid of my x's first, and then I'll deal with my numbers. So I am going to minus 3x minus 3x. And when I do, I end up with a negative 6 is equal to 3. When my x's disappear, I'm either going to get no solution or all real numbers. And in this case, since that's a false statement, no solution. On number 10, I am solving for x. So I want to get that ax by itself. So what I'm going to do is I'm going to minus by from both sides. And I am going to get ax is equal to c minus by. And then I'm going to divide by a, and I'm going to have x is equal to c minus by all over a. For 11, for this one, we're going to plot these points. So I'm going to plot a as negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 1. And b is negative 2, comma, negative 1. And c is negative 2, comma, 7. So 1, 2, 3, 4, 5, 6, 7. And they want us to connect this. So I am going to connect this to make a rectangle. I mean, sorry, a triangle. So let's see. So in this case, let me label the letters. So this one was A, this one was B, this one was C. So they want us to reflect it across the y-axis. So the y-axis is this. This is a y-axis. So I'm going to flip it across the y-axis, which means every point's going to be the same, but on the opposite side. So this is going to be 2 away over here. 2 away over here. So this is going to be C prime. This is going to be B prime. And this one is 1, 2. Well, that was at negative 9. So it's going to be 9 away. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's going to be A prime. So let me connect those. Then the next thing I'm going to do is we want to rotate this purple triangle clockwise 90 degrees. So let me just flip this. So I'm going to do it clockwise 90 degrees, and then take a look at this purple one. And what I'm going to do is I'm going to jot down the points as if this was the direction that my graph is going. I'll do it in orange. So my A double prime is going to be at negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So negative 1, negative 9. My B double prime is going to be at negative 1, negative 2. My C double prime is going to be at 1, 2, 3, 4, 5, 6, 7, negative 2. I'm going to flip this back. And now I'm going to plot those points. Okay, so I have a point at -1, -9. So -1, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's going to be my A double prime. My B is going to be at -1, -2. That is my B double prime. And C is at 7. Here, let me put this on this side. C is 7, -2. So 1, 2, 3, 4, 5, 6, 7, -2. And let me connect these. And that's where A double prime, B double prime, C double prime will be. Now, for number 12, plot the points and make these lines. So I'm going to do this line in purple. So I am going to go to 2, 7, 1, 2, 3, 4, 5, 6, 7, and -2, 1. So -2, 1. And I'm going to draw that line. And my other line, let's say I do it in orange, is going to be 1, 7. 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. Let me draw that line. And then they're asking if these lines are parallel, perpendicular, or neither. Definitely not parallel, that is for sure. Okay, so not parallel. They intersect. Let's see if they are perpendicular. So to see if they're perpendicular, let's find the slope. So for the purple one, let's say I am going up 1, 2, up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. So up 1, 2, 3, 4, 5, 6 over 4. So up 6 over 4. So this slope is going to be 6 over 4 or 3 over 2. Let me look at the orange one. So I'm going to go down 2 over 3. So that's a -2, 3. So this slope is going to be a -2 thirds. So these are going to be perpendicular because the slopes are negative reciprocals. So lines are perpendicular, not because they intersect, but because their slopes are negative reciprocals. So lines are perpendicular since their slopes are negative reciprocal. Okay. On 13 and 14, they want us to write the equation of the lines. Now they want it to be parallel for the first one. So since it's parallel, they're going to have the same slope. So since that slope is a -3, my new line is going to be y equal -3x plus b. We need to find the y-intercept. Now, this point happens to be the y-intercept. So that's going to go in place of this b. So I know my equation is going to be y equal negative 3x minus 1. Now on number 2, we want this time for it to be perpendicular. So if my slope is -2 or -2 over 1, then my perpendicular, that symbol's perpendicular, slope is equal to the negative reciprocal. So since it was negative, it's going to be positive, and then I flip it 1/2. So the equation is going to be y equal 1/2 x plus b. And this point is again a y-intercept. So that's going to go in place of my b. So my equation is going to be y equal 1/2 x minus 1. So in this next one, since we're doing this at home, you don't need to put this into the graphing calculator. They actually give us an equation. What they want us to do is we're going to describe a scatter plot, but let's first create a scatter plot. So I'm going to come over here, come to my add media, go to Google search, and let's do blank graph. And let's see. Let's see, I think I'm going to truncate this a little. Okay, so for this, when I am doing this, I am going to be plotting these points. I'm going to be having my x-axis be length in centimeters. So forearm in centimeters. And my y is going to be height. So this is going to be height in centimeters. I can go by ones on my x-axis. Let's start at 20. So let's say that this is 20. So 1, 2, 3, 4, 5, 25. 1, 2, 3, 4, 5, 30. Then on my y-axis, it's looking like the minimum is 143 and my maximum is 185. So let's see. If I start with 140, and let's see, 2, 4, 6, 8, 10, 150, 2, 4, 6, 8, 10, 160, 2, 4, 6, 2, 4, 6, 8, 10, 170, 2, 4, 6, 8, 10, 180, 2, 4, 6, 8, 10, 190. And then we're going to plot these points. So let's see. 23, 143. So 143, that's 142, 143B in the middle. 26, 160. So 26, 160. 27, 173. 72. So that would be 73 in the middle. 24, 175. 24, 175. So that would be 2, 4, so that's going to be 5. 28, 165, so 28, 165. So 62, 64, 65. 25, 154. 25, 154. 29, 185. 29, 185. So 82, 84, 85. And 21, 147. So 21, 147, that'd be 148. So that'd be 147. So there's my scatter plot. And then they want us to describe the scatter plot. They also want us to interpret they want us to sketch the line. So what I'm going to do is we did not have to generate the line. They actually generated it for us right here. So what I'm going to do is I'm going to substitute in a value to see what I would get out. So let's say that I put into this equation a 20. So if I put 20 in, what do I get out? So let me just kind of do that math over here. So that would be 59 plus 4 times 20. So that's 59 plus 80. So that's going to be 139. It's going to be 139. And then let's say I put in a 30. See what happens when I put in a 30. So if I put in a 30 this time, it's going to be 59 plus 4 times 30. So 59 plus 120. So that's going to be 179. So 179. So let me plot those 2 points. And I'm going to do it in purple. Okay, so 20 comma 139. So 20, 139. And 3179. So 3179 would be right here. So I'm going to draw a line through these points. So let me just extend this line. Okay, so that is my line of best fit. So again, I plugged 2 X values into the equation to see what Y values. And I spread them out a little so I wouldn't have the line be too tiny. I could really see how it flowed. So in this situation, when we describe the scatter plot, we are going to be looking at those sentence frames that are actually on in our, let me see, in our composition book, but here is a copy of them. Describe the scatter plot. So there is and we're either going to say strong or weak. Okay, when we do this, strong or weak, positive or negative, linear or nonlinear, relationship between, and in this case, we're going to say what the X is, which is the forearm length, and the Y, which is the height. So let me go back to our paper. So again, the X is our forearm length in centimeters, and the height is the height of the person in centimeters. So I would say there is and we'll say strong, positive, linear relationship between the length of a forearm in centimeters and the height of the person in centimeters. Okay, these are our sentence frames. Now, when we say interpret the slope, because this equation would really be y equal 59 plus 4x. The 4 is the slope and the 59 is the y-intercept. So when I do this, and I'm going to interpret the slope, again, I'm going to be using these sentence frames. So as the, and here we're going to be talking about the x increases by 1 unit, the y increases or decreases by about. So let's get back to this. So in this case, I'm going to say as the forearm length increases by 1 centimeter, because that's what we are dealing with, the height of the person increases because the line is increasing by what the slope is, which is 4 centimeters. Now interpret the y-intercept. So the y-intercept is going to be the 59. So when I come back to this, so as the, y-intercept, when the blank is 0, so this is when your x is 0. So when the forearm length is 0, the height of the person is about. And sometimes your y-intercept doesn't make sense logically, but we still are going to write it out. So for this one, when the, and this is going to be your x, which is the forearm length, when the forearm length is 0 centimeters, the, and this is your y, height of the person is about, and this is where your y-intercept comes into play, which is the 59, is about 59 centimeters. Now, when we are predicting the height of the humanoid using the model line of best fit, we are trying to predict when they are have their length of the bone, their forearm bone 26 centimeters. It's in the highlighted yellow. So what we're going to do is we're going to plug 26 into the equation. So the equation was y equal 59 plus 4x. So we're going to plug in 26. So we're going to go 59 plus 4 times 26. And when I work this out, let's get in my calculator. 59 plus 4 times 26, I get 163. So 163 centimeters tall is our prediction. Now, when they ask us for the residual is how far off we are. So we're going to take the actual minus predicted for a forearm of 26. So the actual is going to come from our table. So I need to look at the table and see where we have 26. So 26 is 160 centimeters. So I'm going to put 160 centimeters minus my predicted, and my predicted is right there, 163. So we're going to get a residual of a -3. That means we're off by 3. The line was 3 higher than our actual. And we can kind of see that if we go to 26 here. So if I draw a line at 26, let me just draw a line at 26. So here is 26. And you see that my purple line is higher than my prediction. So that distance between those from here to here, that's what my residual is. Okay, and then it says interpret the correlation coefficient if R is 0.75. So we have a sentence frame for this. So since blank is, so this is where we say since R equals whatever the correlation coefficient is, and we're going to say either close to or far from 1 or -1, there is a strong or weak, positive or negative linear relationship between whatever the X and the Y are. So again, these sentence frames are in your composition book. So since, and they're giving us our R right here, R is 0.75. So since R equals 0.75 is, and we're either going to say close to or far from 1, since this is a positive. So is, I'd say close to 1. There is a strong positive linear relationship between the X and the Y, and the X is the forearm length. So relationship between the forearm length in centimeters and a person's height in centimeters. And that's the end of this video.